Okay, in this section 9.4, we're taking a closer look at exponential decay. And so we're kind of building on some of the things that we learned from 9.3. And we'll start off by looking at some of the same characteristics of an exponential function. We have the general form here. We know that A is the initial amount. This is just a review. All right, the initial amount. We know that B is going to be our decay factor. And of course, X is still going to be time. And remember, the value of B tells you whether it's growth or decay. If B is greater than 1, then the graph is exponential growth. If the B is between 0 and 1, between 0 and 1, then the graph is exponential decay. All right, so here's an exponential function that we'll have to identify several characteristics about. So y equals 3 times 0.5 to the x power. The A is easily identifiable as 3. The B also, we know, is 0.5. So those are easy to determine when it's in this form. Now, do we have growth or do we have decay? Well, to figure that out, we need to look at the value of B. And remember our chart here. If B is greater than 1, then you have exponential growth. If it's between 0 and 1, we have exponential decay. 0.5 is between 0 and 1, and that means we have decay here. My x or my y-intercept, the place where it crosses the y-axis, we could graph it and trace it to find the y-intercept. Just by looking here, it looks like 1, 2, 3. It looks like 3, but remember, just by looking, you can't tell if it's 3.01 or 2.99. And so, in order to make sure we know, remember, the y-intercept is the place where the x is 0. The x value of 0 on the graph, that's where your y-intercept is. Well, if I put in a 0 here for this, 0.5 to the 0 power is 1, and 1 times 3 is 3. So my y-intercept has to be 3. When it's in this form, the A is the y-intercept. The initial amount, that's at time 0. And so time 0 is your y-intercept, right? So the initial amount, whatever you start with, that's always going to be your y-intercept when it's in this form. So if you want to know what the y-intercept is, just look at the value of A. It's 3, verified by the graph as well. Now we need to find the domain and range. All right, so remember, we're asked domain and range about every function that we study, going all the way back to the beginning of last semester. And so exponentials are no different. We have to be able to identify domain and range. Remember what we said, domain are the x values, range is the y values. If you remember that alphabetically, they're both alphabetical. D comes before R, X comes before Y, so you'll never forget which one is which. And so domain, how are we going to figure it out? Well, remember, when you're looking for domain, you need to look for boundaries. Is there, and remember, domain is the x-axis, x values we're looking at. Is there a lower bound on the x? All right, lower bound on the x. Well, remember, this arrow indicates that it keeps going, right? And so there is no lower bound. It'll eventually get to all of those numbers. And also, there's no upper bound because it comes this way and keeps going this way forever. All right, so there's no lower bound, there's no upper bound. That means every number counts. Mathematically speaking, the phrase is called all real numbers. Meaning there's no limitation on the domain. You can put any number you want in for the domain. The range now, we're looking at the y side of this. There is a boundary on the y side because this graph will never get lower than this 0 line. So 0 is actually the lower bound, and then everything above that counts. And so our domain is going to be y. Now, we need to figure out whether that's just greater than 0, or do we need an equal to under here. We don't need an equal to under here because, remember, the graph approaches 0, but it never gets there. That's your horizontal asymptote. And we need to go back up here and take a look at this. I didn't point this out to you, but we had it from the last section. So what's an asymptote? It's an imaginary horizontal line. For this section's purposes, it's horizontal. You can have vertical asymptotes, but for exponential functions, it's a horizontal line that the graph approaches but never crosses, and as a matter of fact, never actually touches. All right, it never touches that imaginary line. And then y equals the y value. The graph approaches, but it doesn't cross. All right, so that's the form for a horizontal asymptote. It's going to be, the equation for it is going to be y equals some number, and that's the number that it never actually reaches. So here we get closer and closer to 0, but we never actually get there. So my horizontal asymptote is going to be y equals 0. And I can show you this on a table of values as well, kind of like what we did in the last section. And so and you can do this on your calculator as well. Might as well show it to you on your calculator. I think I showed you it on Desmos last time, which is a calculator app you can get on your phone that works really well. So if I go to my graph now, here's what it looks like on our calculator. If this thing will come up, I'll show you. And I'm going to grab another one, see if it's ready to go. All right, so now we got one. All right, so I go down here to the graph, and I'm going to plug this in. 3, open a set of parentheses, 0.5, close, and raise it up to the x power. All right. Here's my graph. Control T is what gives me the table of values. And now let's take a look and see what's happening here. All right. Obviously, if I go the negative direction, it gets bigger very quickly, exponentially, as a matter of fact. Now, if I come this way, remember, notice that it's getting closer and closer to 0, but it's never actually reaching there. I'm out to 20 now, and it's 0.00003. Still didn't reach 0. 0.0001. Still didn't reach 0. Now it's listing the answer in exponential notation. So e to the negative 7th means you take this decimal point and move it over 7 spaces to the left, and you'll fill in those spaces with zeros. So really what this number is 0.6 more zeros and then 178. All right. So it's this number that it's at now is 0.0000001781139 and so on. All right, so still doesn't reach 0, still doesn't reach 0. So we got 10 zeros in front of this number now. 11, 12, 13, 14, 15, 16 zeros, 17 zeros, 18 zeros. So this number now at 66, all right, when x is 66, the y is 0.000000020 of those zeros, and then 4065. So it's never going to reach 0, guys. It gets close, but it never reaches it because 0 is the vertical asymptote. All right? And so that'll give you everything that you need to complete your quiz for section 9-4 in Canvas.